Hi everyone, let's get started with section 4.3, Maxima and Minima. In this section, we are going to use derivatives to find the largest and smallest values of a function. These ideas are really important for two big reasons. First, they help us graph functions more accurately. And second, they help us solve real-world problems, especially ones where we want to maximize or minimize something, like profit, distance, or cost. Let's start with some definitions. An absolute maximum is the largest value of a function on a given interval. An absolute minimum is the smallest value of a function on that interval. We use the term absolute extrema to refer to both of these together, the highest and the lowest values. Now, let's look at the graph. We have a function f of x equals x squared plus 1. You can see that this graph is a parabola opening upward. The lowest point of this graph is at the bottom of the curve. That point is the absolute minimum because no other point on the graph has a smaller value. And notice, this graph actually does not have an absolute maximum if we consider all x values because it keeps going up forever. Now, let's make this more precise. We say a function f has an absolute maximum at c if f of c is greater than all other values of f of x on the interval. Similarly, a function f has an absolute minimum at c if f of c is less than all other values of f of x. There are a couple of important things to keep in mind. First, absolute does not mean absolute value. Absolute just means the highest or lowest over the entire interval we're looking at. Second, be careful about the notation. The value is f of c. That is the output or the y value. And c is the input or the x value where that maximum or minimum happens. So, to summarize, absolute maximum is the highest value. Absolute minimum is the lowest value. And both together are called absolute extrema.